Critical Thinking Rule 15. Seek impartial sources. Impartial means not biased. So an impartial source evaluates all available information or evidence fairly and objectively. It doesn't favor some evidence over others. So it has a kind of balance, similar to the idea of justice. So what's the difference between being informed and impartial? We want the sources we cite to both be informed and impartial, but we need to be clear on what the difference is, because the same source can be one and not the other. An informed source is one that has lots of information or knowledge. An impartial source is one that uses that information rationally. So it takes all the available evidence and it figures out what is most likely or probable to follow from that evidence taken as a whole without overlooking or overemphasizing certain parts of it. So try to think of an example of a source that would be informed but not impartial, i.e. would be informed but biased. A good example of that might be a mechanic, someone who knows a lot about cars, but some mechanics can be biased if they want to make more money from you. So you take your car in, it's having problems. They know what the problem is, but because they can earn more money if they say it's a more expensive or bigger problem, they may be biased in terms of the information they give to you. So Rule 15 says to seek out impartial sources. We're going to go through some of the criteria for impartiality, or some of the types of sources that often count as impartial. One reason why a source can be regarded as impartial is if it does not have a financial stake in the outcome, in the information they're providing. So for example, the seller of a product is going to be a partial or biased source. They're not going to be impartial. So if you go to Apple and ask them if they have good cellular phones, they're going to have a huge incentive to say yes because they want to sell them. So advertising by companies and other marketing communication generally does not count as an impartial source. Another criterion for being impartial is that the source does not have a strong ideological stake. So for example, politicians or political activists or even individual people with a strong political or religious ideology will not be impartial sources on a given topic. The source does not have a personal or emotional stake. So for example, if you ask a parent if you think their child is smart, they're probably going to be a biased source of information. Even though they're highly informed about their child, they're not going to be impartial in terms of how they assess that information. And another criterion for impartiality, or another way a source can be impartial, is if they have a prior interest in accuracy. That's why I'm using Consumer Reports as an example. Consumer Reports makes money from the information they provide. That's their business model. How is to sell issues of a print magazine or to sell ads on their website. However, because they're only valuable to their audience if they provide accurate information, they can be regarded as an impartial source on the various devices or consumer goods that they review. So it's really different from the manufacturer or seller of a given product. The Consumer Reports is just reviewing those products, and their business is providing information impartially. So some examples of sources that are often impartial. University scientists, as long as they're not getting their funding from a company that sells a product, then they may be an impartial source of information. They do have an incentive to further their career, but oftentimes the best way of doing that is providing information that's as accurate as possible to convince their peers that it actually is worth paying attention to. Another type of source that's often impartial is a statistical database. Now, it could depend on who compiles the database, but oftentimes databases are compiled for use by a wide variety of researchers or organizations. So the compilers of the database have an incentive to just be as unbiased, as impartial as possible to make that database as widely useful as possible. Another type of source that's often impartial is a source that provides an independent rating or review, such as Consumer Reports. If it's a biased source, then it would become common knowledge that they were less reliable. They would get less customers, or they would get fewer views on their web pages, and so they would lose money. So they actually have a financial incentive to try to be as unbiased as possible. Another example is a government agency, provided they're not under a lot of political pressure. So if they have a degree of political independence or autonomy, government agencies can actually be good sources of information. What about biased sources? These are ones that have the opposite characteristics. Either they have a financial stake, like a company selling a product, an ideological stake, such as a political activist group or a politician, or even a news organization like Fox that has a political bias. And yes, this also happens on the left, not just on the right. Then that could bias or taint the source's information. Another source of bias is the personal or emotional stake, and if they don't have a prior interest in accuracy. So if their business model, for example, is getting clicks or getting people to read their material or view their videos, then they may just feed into a partisan or ideological line, and it can make people feel good. As consumers of information, we oftentimes want to be fed information that confirms our pre-existing biases. So a lot of organizations, their business model is to tap into that. So they're not going to be an unbiased source of information. And then another type of bias is if the source is related to the person they're evaluating. That could fall under number 3, having a personal or emotional stake, but it's important enough that it deserves separate discussion. This is called nepotism, when you are favorable towards people you have a personal relationship to. Some examples of sources that are biases in this way could be interest groups or advocacy groups, including various types of activists, such as guns rights activists or civil rights activists. They're not going to look at any news event impartially if it impacts on their issue. Manufacturers or sellers of a product, politicians, politically affiliated news organizations, and government agencies that are subject to political pressure. So this really varies from government to government and from agency to agency. So for example, in the United States, the central bank is actually, the Fed is actually traditionally relatively independent of political oversight, whereas other government agencies can be more subject to direct political pressure. It also varies from presidential administration to administration how much pressure the president is putting on any particular agency. Another thing to be aware of is not just the particular sources of biases we were talking about on previous slides, but general human cognitive biases that are present in all of us, regardless of our beliefs, to varying degrees. So these can bias a source even if they don't have a financial, ideological, or other stake. So an example of this is the confirmation bias you can see there in the cartoon. I did 6 experiments, but only 1 supported our hypothesis. Well, let's only submit that experiment in the grant proposal. What about the other 5? Human error. So this is an illustration of how confirmation bias can sometimes operate in scientific settings in the lab. So basically, if the researcher wants a certain result because it might be interesting or important, then they may only pay attention to experimental trials or other evidence that confirms that result and overlook, downplay, or cut out information that conflicts with it. So the confirmation bias can be defined as emphasizing evidence that supports a claim while downplaying evidence that conflicts with the claim. Another type of bias that can operate is overconfidence bias, which is the tendency to overestimate the probability of one's beliefs or abilities. This also applies to all humans. An example of this, famous example, was a study published in 1981 by the Swedish researcher Ola Svensson, which found that 93% of Americans rated themselves as better drivers than the median driver. The median is the driver that's in the middle in terms of their driving ability. So this means that a large fraction of Americans are overconfident in their driving ability. And this is something that applies across many different contexts. So let's look at some of the various biases that operate in scientific research. The thing is, scientific research is in general the best source of information. It tends to be the most informed and the least biased. So this is not meant to impugn the credibility of science, far from it. However, we have to be very nuanced and careful as critical thinkers. Even though scientific studies are the best things to cite, we also want to be on the lookout for potential sources of bias even when it comes to science. So one example of potential for bias is government-funded research, if the researchers have an incentive to please superiors. Now this really varies from case to case. Like I said, from agency to agency, from administration to administration, from nation to nation. So you have to be judicious in how you apply this and dig a little bit deeper. You can't just say, oh, it's government funded research is biased, so we can ignore it. You have to be more in-depth than that. However, there can be cases where researchers have incentive to please their superiors. One example of this was in 2003, when former Secretary of State of the United States, Colin Powell, made a speech about weapons of mass destruction in Iraq before the United Nations Security Council. Now, this was not research that had been compiled by scientists per se, but it was research that had been compiled by intelligence experts at the CIA. However, George W. Bush, who was the president at the time, had put a lot of political pressure among the intelligence agency to provide information that would support the case for war with Iraq. And so that tainted the analysis and that tainted the information that Powell presented before the UN. Another source of potential bias of science is when you have scientific research funded by industry, i.e. businesses that produce the products relevant to the research. A well-known example of this is pharmaceutical companies. They have to fund a lot of research to prove the safety and effectiveness of their pharmaceuticals. However, they have a huge financial incentive to make it look as if their products are safe and effective, and they can put pressure on the researchers who work in their labs. Another potential source of bias is among the researchers themselves. This can happen even when they don't have a direct financial or ideological stake. They may have an incentive to produce new and surprising findings, which can make it more likely that their study will be published and noticed by others, which can further their career. This is known sometimes as the file drawer problem, or one aspect of this researcher bias is the file drawer problem, alluded to in the cartoon in the previous slide, when if a researcher finds information which conflicts with the hypothesis they want to prove, they may just ignore that particular trial or information and publish the ones which get the result that they want. Similarly, even at the level of journals which publish particular scientific studies, most scientific journals operate through peer review, which means that before a study can be published, it has to be checked by other researchers who are experts in the type of study it is. And so this can serve as a type of editorial check among information that may be implausible, or against studies that may have a flawed methodology, and so on. However, the editors of a journal themselves have incentive to publish findings that are new, interesting, and that prove something definitively. It's less interesting in general to publish, oh, we tried out this hypothesis, but it didn't work. So because that's inherently less interesting or novel, even if it's an important piece of information, this hypothesis turned out to not have evidence for it, that may never be published in journals. And if you think about it, if you have a bunch of scientists studying a new hypothesis, suppose one scientist or one team of scientists finds information that confirms it, but 19 scientists find information that does not confirm it. So they fail to confirm the hypothesis. It's possible that that confirmation alone will be published, and it'll make it seem like, oh, all of the scientific evidence is in favor of that hypothesis, when in fact, the vast majority of the evidence was against it. Now, it must be said that scientists are becoming much more sensitive and aware of all of these problems. And so the culture of both individual journals and science as a whole is starting to lean against the file drawer problem and to lean against the only published new, interesting, positive findings. So it's more likely today that you would have publication of negative or no effect findings and also publication of failure to replicate or reproduce the findings of previous researchers. But it still is a bit of a problem. Next up, Rule 16, cross-check your sources.